Hi, I'm Miss Ulrich, and in this video, I'm going to teach you about domain and range on continuous graphs.
Alright, so again, this video is going to cover domain and range on continuous graphs this time. So remember, we learned last time that the domain is the set of x's in a function, and range is the set of y's in a function. So you have to look to the x-axis for the domain or the y-axis for the range to determine the dimensions of the graph. So when we look at domain and range on continuous graphs, we're not just looking at the integers anymore, we're looking at all the numbers that fall between. And we're going to use inequalities to determine those the range of numbers. So for an inequality, remember we had two different types of inequality signs. We had a less than or a less than or equal to. And we talked about when we looked at this before on inequalities that when we have a less than sign, we have what's called an open circle. It means that it doesn't include the number, it goes around it, but it doesn't actually include that number specifically. A less than or equal to, though, does include it because it's also equal to, so it's what we refer to as a closed circle. It's colored in all the way. So we're going to use these again to determine the domain and ranges. So to start off with, remember our domain are the set of all the x's. So we're looking at the x-axis, which is right here, to determine the domain. And we're looking always from least to greatest. So we're looking for the smallest number on the x-axis all the way out to the largest number. So the smallest number, the first point I come to, moving from left to right, would be at this -3 here. And if I move across the graph, the largest number I come to is right here at this +3. So that means my dimensions for this range from -3 to a +3. Now, to show I'm talking about the domain, I'm always going to put the x in the middle. And then to include all the numbers in between, I'm going to use my inequality signs. And that's where this open circle and closed circle comes in. So at the -3, notice, it's an open circle. That means it's going to be a less than sign. And at the +3, it's going to be a closed circle, which means it's also a less than or equal to sign. So this would be my domain. The domain falls from -3 to +3, and it says -3 is less than x, which is less than or equal to +3. Now, it's the same concept for the range. On the range, remember, we're talking about all of my y values. So I'm looking at the y-axis, and again, I'm looking from the least to the greatest, so the smallest to the largest. And that means I'm moving from bottom to top. So the very last point on this graph is at this -3 here. And if I move all the way up, the tallest point on it is at this +3 here. So again, my range goes from -3 to +3. And I'm talking about y this time, so that's the variable I put in the middle. And then now I have to look at my open circle versus closed circle. So the -3, I have a closed circle. That means it includes it, so it's also going to be less than or equal to. And then at the +3, it's an open circle, so it's just a less than. So this means that our y, our range, falls between -3 and 3. And -3 is less than or equal to y, which is less than or equal to +3. So the same concepts continue for this second graph. So again, the domain covers all the x values, and we're looking at this x-axis right here. And we want to always write it from least to greatest. So looking at this, this is the first point that I come to, the smallest point on the x-axis, and that's at -8. And then we go all the way out to this point here, which is at a +6. So that means my domain goes from -8 to a +6. And again, I put that x in the middle there to show I'm talking about the domain. Now at the -8, it's a closed circle, so that means it's going to be a less than or equal to sign. And at the 6, it's an open circle, which means it's just a less than sign. So this would be my domain. My domain is -8 is less than or equal to x, which is less than 6. Now the range again is all the y values, so we're looking at the y-axis to determine the range here. And it's still writing it from least to greatest. So the smallest point is down here at a -8. And the largest point is up here at a +6. So that means my range goes from -8 to a +6. And I'm going to put that y in there to show that I'm talking about the range. At the -8, it's an open circle, so that means it's just a less than. And at the 6, it's a closed circle, which means it's less than or equal to. So this would be my range. We go from -8, which is less than y, which is less than or equal to 6. Now let's look at some where we don't necessarily have open circles and closed circles. And here you're going to notice we have some arrows. So again, we're still talking about the domain, which is all the x values, and that's looking at the x-axis. We're still writing it from least to greatest. So the first point I'm going to come to is actually this line right here, which is at a -2. Now, what you're going to notice is this graph goes all the way out, and you're going to see arrows on either end. Well, arrows mean that it keeps on going, so there actually is no maximum to this graph. It's going to continue on and on and on into infinity. So this one, in this domain, is going to be written a little bit different. We're going to have -2 is less than or equal to x. There's no maximum number here, so that's why there's no other side to this domain. It's simply just what is written here. -2 is less than or equal to x. That means x can be any number greater than or equal to -2 as the graph shows. Now, range again is all the y values, and so we're looking at the y-axis here, and we're looking from bottom to top, smallest to largest. And again, what you're going to see is this arrow on the end, on the bottom, which means there's no minimum here. It's going to continue to go down forever and ever and ever. On the top here, again, we have this arrow. So there's no maximum value either. It goes from -infinity to +infinity all the way on the range. So there's no minimum and there's no maximum. When this happens to where there's no minimum or no maximum value, it can be any number, literally from -infinity to +infinity. So we write this by saying all real numbers. So all real numbers would be our final answer for the range here. You can write it out, or you can write the symbol for it. And the symbol for all real numbers looks like this. So you'll see me write this a lot, and you'll also see this on tests and quizzes to symbolize that the domain or the range could be all real numbers. Right, same concept goes for this graph. We're going to see the domain again. So the domain is all of the x values, and we're looking at the x-axis here. So we don't have points anymore, no open circles or closed circles. We have arrows. So on the far left side of the graph, we have an arrow, which means it continues to go to the left. And then on the right side, we also have an arrow, which means it continues to go to the right. So again, this is a no minimum or no maximum value for the domain. This means that our solution, our answer for the domain, would be all real numbers. And again, that means that it goes from -infinity to +infinity. And remember, the symbol for all real numbers is this. And again, you'll see me write that a lot on tests and quizzes. Now, the range, remember, are the y values. So we're going to look on the y-axis. We're looking for first a minimum value. And what you're going to see again is that there's arrows on either end. So that means it continues to go down as far as we can possibly go to -infinity. However, there is a cap on this. The maximum point on this graph is at 4. So the way I'm going to show this, there's no minimum value. So we're going to start with y has to be less than or equal to 4. So basically that's saying y is any number less than or equal to 4. This would be our range for this graph. Alright, so let's talk about this one. We're back to having endpoints on this one. So remember, domain are all the x's. So we're going to look at the x-axis here. Smallest to largest, the smallest point is right here at -3, and the largest point here is at a +3. So our domain goes from -3 to a +3. The x's goes in the middle to show we're talking about our domain. And at both ends here we have a closed circle, so that means that both -3 and +3 are included. So x is between -3 and +3 on our domain. For the range, we talk about the y values. So again, that's to look at the y-axis here. And we're looking again from smallest to largest. So the smallest point here is at -3, and the largest point is at +3. So again, our range goes from -3 to a +3. We'll put the y in the middle to show we're talking about range. And at both ends, we still include that -3 and +3. So it's going to be equal to in both cases. So y falls between -3 and +3 on our range as well. All right, let's look at our domain for this one. This one we kind of have an oval shape here. Our domain, we're still going to look at our x values, so we're looking at the x-axis. And notice where our points are at on the x-axis. We are at a -4 for our smallest and at +4 for our largest. Now, at those points, it does actually include those numbers. There's no open circle or closed circle. We just know it touches it. So it's actually going to be a less than or equal to at both cases. So x is between -4 and +4 on our domain. And for our range, we're going to look at the y values. So in looking at our y values, we kind of see the same thing. We're looking for the smallest, which is at -3, and the largest, which is at a positive 3. So our range goes from negative 3 to a positive 3. I'm going to put the y in the middle to show we're talking about the range. And then make sure, again, it does actually include both of those points. It touches it. So we're going to have a less than sign and an equal to sign at each of them. So negative 3 is less than or equal to y, which is less than or equal to 3. And this would be my range for this graph. Now, number 7 asks on this one if this is a function. And remember, we determine if it's a function to see if any of the x's can repeat itself. And on a graph, we're looking for it to pass the vertical line test. The vertical line test says I can draw a vertical line through any point on the graph, and it should not cross more than one point on my graph. So if I draw a vertical line, notice how it crosses here and here on my graph. It would do that at every point just about because it's an oval shape. It has symmetry to it. So here and here it crosses twice. Therefore, it does not pass the vertical line test, which means this is not a function technically. Even though it's a circle and we can identify a domain and range for it, it is not a function. So for this last one here, we are asked to create a graph with a domain of negative 2 to 3 and a range of negative 4 to 5. So let's start with my domain. Remember, the domain are all the x's, so I'm looking at the x-axis here. And I'm going from negative 2, which means that's this point right here, all the way to 3, which is this point right here. Okay, and the range, I'm looking on the y-axis, and the range goes from a negative 4 to a positive 5. So what I'm going to look at here is trying to match my points up so that I have a graph that has this correct domain. Well, in order to do that, we need to know where to put our points. So first thing, notice that at the negative 2 and the 4, we have a closed, or what would be a closed circle. It's less than or equal to, which means it's going to be closed. So at that point, I'm going to go ahead and put a closed circle here. Now, opposite of that, at the 3 and the 5, it's a less than sign, which means it's an open circle. So at 3 and 5, I'm going to put an open circle. And then I can do anything in between here as long as I don't go outside these boundaries. So any graph that falls in between these two would be a function with a domain and a range that fall in this particular category. And again, I got that by basically plotting two separate points, negative 2, 4, and 3, 5. And that's what you'll see on my graph.
So I hope that helped you to understand how to use inequalities to write domain and range on continuous graphs. Remember, keep watching for more information and ask questions in class to get clarification. I'll see you next time.